Hi everyone, sorry about that. Apologies for all the technical difficulties today. We're talking about the solar radiation when it gets to the Earth's surface and how it's partitioned into the stuff that makes things heat up, the sensible heat, and to the stuff that makes things evaporate, the latent heat. So you can consider in a desert environment where there's little, if any, water around to evaporate or for plants to transpire with, that energy from the sun is pretty much converted into sensible heat. That is the heating things up in the environment. In contrast, you can think about an area well watered, for example, an irrigated cropping area. Solar energy has lots of water to evaporate, lots of water for transpiration to occur. So this would be a situation where the latent heat flux or latent heating would be greater than the sensible heat flux. And as a consequence, you'll see the overlying atmosphere of a cropping area like this be cooler because of the latent heating, the evaporative cooling. So that's all about land-atmosphere interactions for now. We covered a lot of ground today, covered a lot of sky, if you like. We talked about the Earth's atmosphere and how it's stratified into horizontally homogeneous layers that we know as the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. We focused on the troposphere because that's where we live and it's where all the weather we come to depend on a day-to-day basis happens. We talked about the physical properties of Earth's atmosphere in terms of the pressure, temperature, and moisture distributions. Pressure, temperature, and therefore volume and density of a gas and how they're related through the ideal gas law or the equation of state. Key concept about water vapor being concentrated in the lower part of the atmosphere. It's where we get our weather, it's where our rainfall occurs. And also this idea, another key concept is to think about, to remember is the how warm air can hold more moisture than cold air. So where we have the same amount of moisture in two different air parcels, for example, cooler one and a warmer one, the relative humidity different despite the same amount of moisture in those two air parcels. We talked about the atmospheric composition. We talked about the well-mixed component. Nitrogen dominates the air we breathe. 78% of it's nitrogen and then oxygen followed by argon. So that's the stuff that no matter where you go on Earth, you look at the composition of the air and these will be the ratios you'll find. Talk about the greenhouse gases. Water and CO2 is the most important of the greenhouse gases, followed by methane and nitrous oxide. They're important because of what they do to the heat trapping in the energy balance, energy budget. Aerosols, these are the suspended particles of dust, ash, sea spray, etc. in the atmosphere. They may have a role in global cooling, but they definitely have a role in making clouds and therefore rain. So they're important for that aspect alone. And finally, we looked at land-atmosphere interactions, focusing on how we can characterize a surface in terms of albedo, the amount it reflects, versus and its emissive properties, how much it emits compared to how much it absorbs. How they can then be used to partition the long and short wave radiation components into energy that goes into evapotranspiration and surface heating. Thank you, and we'll see you next time.